So I think that we can move on with our next speaker, and let me welcome on Javon Conference Andres Rivera. Andres, hola, buenos días, bienvenido a Javon.
Hola a todos, bienvenidos. Gracias por la bienvenida. Hello everyone.
Hello, hello. So, guys, if you understand our chit chat with Andres just a bit, just write something in Spanish in the chat so we would know that we are not alone here. So, before we dive into your topic, Andres, maybe you can give us just a small hint. What would be your topic about?
Sorry again.
Yeah, no worries. Can you just give a small hint? What would be your topic about?
Oh, yes, of course. Today we will talk about NCP protocol servers that it's used it's used to connect our agent AI with or to give more additional tools to our LLM models. Well, that's the topic for today. Also, uh, a lot of conference about MCPs are focusing on Python, most of them, and JavaScript, but not most of that conferences are focusing on using Java and show how to connect our HCP services with IntelliJ.
Okay, cool. So you can share your screen meanwhile, and while you're doing so, I will ask one more time people to use our chats to asking questions. So you can do it in both English, Spanish, and maybe any other language. So I will try to translate them. Yeah, use both chats on the community platform and YouTube. I will monitor. Will and still monitoring both of the chats, and I will ask your questions in the end of the talk. Don't forget to rate our speakers and rate their talks and give badges. This is really valuable and kinda cool. Uh,
Well, let's present. I will share my
yeah.
screen. Share screen. Okay. The screen. This one. Okay. Are you seeing my screen?
Just give us a second. Yeah, we can see it. Okay. All
Oh,
is ready. All is good. Good luck,
okay.
and
Okay.
let's
Great.
go.
Perfect. Then let's start. Well, for today we will talking about MCP services, of course. A little about me. I am a lead software engineer here in EPAM since 2022. Well, I am a coffee lover. Here in Colombia, it's really common to find a lot of cafes, and all of them try the best to give you the best experience just in a cup of coffee. And also, I like to go to the gym every day, Monday to Friday. Well, and also about my IMAS, this was my dog, my bitch, and this one are their puppies. It was amazing to have all of them running and playing with them. And well, I guess that represents a little about my hobbies. Well, let's go to business. This is the agenda for today. We will discuss or give a little overview about what is an NCP, the core concepts, some differences with other technologies, um, a lot of things about security essentials, the NCP ecosystems, and later the hands-on for the last part. Uh, MCP basically means Model Context Protocol. It's a way to communicate easily with our agents AI, as I said, and to provide tools to additional tools to our large language models. Key points about the NCPs was created. This protocol was created by Anthropic last year. Anthropic decided to give a license for this one as an open source. It let us or enables AI as assistants to access external data or tools in a securely way. Also, the architecture for MCPs is a client-server architecture, and it's language agnostic. Sorry, it uses JSON RPC to communicate with our agents. What NCP solves? Basically, LLMs are powerful, but normally that kind of models are isolated. They can access external information or, for example, business data or private data. Lack of real-time data. They don't have, before MCP, we don't have any standard way to access external APIs or files inside our laptops, our computers, or give other kind of tools, like, for example, access to specific methods that return business logic. Then, before the NCPs, this is the scenario that we have. For example, if we require to connect our large language model with YouTube, YouTube have to offer, or maybe we have to create an API to access our specific channel and provide with that information to our LLM. Or if we want that our LLM communicate with Slack and with our project Slack, for example, we have to create an API, or each of these tools were creating its own solutions to communicate with our large language model. Then, when later of that, Anthropic was thinking in a single protocol that let us communicate with our large language model in a easy way. And what we have here is our models, Cloud, GPT, or maybe Oyama or another one. Just have to know one single protocol, and our NCP translate all of that to provide with to the model with that specific tools, or to give access to that specific tools. Here, to understand the actual AI ecosystem, we can review this little diagram where the AI agents are presented as the orchestrator in the middle. The AI agents receive the prompt, this goes to the model to translate that prompt that it's given in natural language, but the AI agent requires to have that information in a matching language. Then later of that, it decides to go to a NCP server. It requires a specific tool for that. And from here, we have different MCP services that give access to different tools. For example, this one give access to a database server. Maybe the prompt it's about create a report about the last or the sales month, the month sales for for the actual month, and it will require to get that information from our database. The AI agent will decide to give that information to the model and finally return a report in a maybe in a PDF format. Here we explain a little what are the different the different functionalities for the LLM, the AI agent, and the MCP server. As you can see, the main function for the model it's basically processing the language, and the AI agent it's executing complex tasks, orchestrate finally. Here we have an example about how it works. The AI agent will receive the prompt. The LLM will translate the prompt in a matching language. It will decide the steps required to that prompt. Later, in the steps, first of all, we require to go to the database to get information about sales data. We will give that information to the LLM. It will analyze that information, generate the insights, and create a report in a format asked in the prompt. Later of that, we have to go again to the NCP because inside the prompt, we have the order that send a report via email. Then we will use the NCP to do that specific task. And finally, we will respond to the user that everything, that the report was created and sent it by email. That is the best example for this one. Let's see what is the NCP architecture. Well, basically, we have here the AI assistants. The AI assistant probably is created by one of these ones. For example, Cloud has its own chat, GPT also, or inside our IDEs, for example, IntelliJ has also, it let us add plugins that has that NCP client. The NCP client communicates through the JSON protocol to our NCP services. And inside the NCP services, we could have resources. Resources are, for example, databases or files, or we could have tools that go against the databases and maybe add a security layer, for example. Or we can have also prompts. The idea to have prompts through an NCP server is to provide to all the organization with the same same standard prompts, and we will see how it works in our demo. Okay, let's continue. Let's go to each of these ones in our MCP services. As I said, resources. Well, resources could be a database or a file, maybe messages, are only read only. That's a big difference with tools. Could be static or dynamic, and are identified by an URI schema, and well, support templating for dynamic content. Let's continue. Let's see about tools. Tools execute specific operations, can modify the state. We will see what is this one in our next slide. Can return structured results. And well, here are some examples of that. For example, execute a query or send an email, as we saw in our example, or maybe create a Jira ticket or review a PR, something like that. And here it's the big difference between resources and tools. The resources can modify the state, the tools can modify the states, but resources are thinking more as read-only, required to access specific files. Then we can create here a method that go and review that specific file or access that specific file, or maybe get information from our database for a specific user, or maybe give us the log information to do an analysis about something that is presenting in production, or trying to review some or giving alerts about our applications in production, just reviewing the logs. But all of that, it's read-only. Tools could modify or could update information. For example, we can write a specific file, or we can create a user in our database, or we can cancel an order using an API, something like that. And finally, prompts. These one are just predefined prompt templates. Could include dynamic arguments. It encapsulates best practices. That's the idea, to use an MCP server to distribute that template prompts in our organization. And well, some examples are code review checklists. We can create a template prompt to do that and distribute it to all the developers team. Bug report template, architecture decision template, and other examples. Let's talk about differences with actual or with other technologies like REST APIs. Basically, REST APIs are thinking to communicate to human or other APIs, or to give integrations with humans or front-end applications or API or other APIs. The discovery, it's through manuals. The MCP give us automatic introspection. The schema used in an API is Open API, for example. But by MCP, it's always JSON schema. The context, as we know, APIs are commonly stateless. NCPs save the context of the communication. Uh, they are thinking, the NCPs are thinking to be optimized for large language models. APIs are thinking to be to communicate or for other purpose. And the standardization about APIs, it depends on the project, as we saw at the beginning. But NCP is just a single protocol. Okay, before NCPs, a way to cover or to give tools to our large language model was using function calling. Basically, for example, for GPT, they have its own SDK where we can use a specific function calling with a specific parameters. But it's the way how GPT solve the problem about how to give tools to their model. But with NCP, all our models knows that we have same standard to call a specific tool. When we are adding a new tool, it's just giving the name of the tool, a schema that it's JSON RPC, and a handler that it's the function in charge to provide the functionality to our LLM. Okay, well, here it's basically the same as I said. Here it's an example about what is function calling. As you can see, we have to do using this approach. All LLM have to provide or have to be in charge to do all of these ones, all of these tasks. As you can see, for example, the user is using DeepSeek in this diagram. The DeepSeek has some function definitions, but there are specifically for DeepSeek. It will decide what function have to call to get the information required for the prompt, and finally integrate, get that information and generate the answer for the user. User NCP, as you can see, the NCP, we will have an NCP client here, or even better, an agent AI. And the agent AI will orchestrate everything. Will call the large language model, will call the NCP servers to get access to the tools. With that information, it will send that information to the large language model, and finally provide the answer to the user. Well, let's talk about security essentials. Basically, for NCP services, it use same security architectures that we consider for APIs. Here, for example, about the authentication and authorization, we can use a client identity by providing an API key, or using an OAuth, or using MTLLs. we can implement also role-based access control, or we can add audit logging. Um, about the input, it's important to validate what is the input to our NCP service, to sanitize that entry, and prevent to injection attacks. And well, we can limiting the number of requests against our NCP service, thinking on reducing costs, enhancing security, mitigating security risks, and also managing system load and scalability, or prevent resource starvation. The way to do that is the same that we are using for our APIs. For example, it's adding a rate limiter here before calling the NCP service. And yeah, I don't know if all of you are familiar with this one, but for example, in AWS, it's just creating a policy to limit the number of requests to our services. That could be limited by region also, or if by users. Yeah, there are a lot of possibilities, but we are using exactly what we have in the market right now, but just implemented that for our NCP services. Another thing that it's really important to have, it's about the data access control. We are using exactly the same principles. For that, we have to filter in passwords, keys, personal information. We have to have in our mind the principle of least privilege, and also thinking of respect the existing permissions. We can do that. For example, if we try to go to a database, it's better access the database not directly. Even better is go through an API that had all or to manage all the access permissions required for our database. And this one is another way to manage security for our NCP, and it proposed to have a sandboxing or to have a sandbox or to install our NCP service inside a sandbox container. It let us isolate tool execution, limiting the usage of our resources, and also we can have a timeout for our operations. It prevents, for example, infinity loops. That it's a problem when we are managing a multi-agent. For example, multi-agent AI has that known problem, and well, this is a way to limit that or to prevent that. And this one, it's another it's a final approach that is right now using for NCP. It's called NCP proxy. The idea is to provide our NCP services. Before go to our NCP services, we will have a proxy that will wrap all that security essentials we saw before, like the authentication, rate limiting. We can have also load balancing for our NCPs. We can add monitoring, caching. Yeah, the idea of this one is encapsulate all that security essentials. Well, about the NCP ecosystems, we have the official implementations in Anthropic. If you go to the Anthropic page here, you can see all SDK implementations for each of these languages. Also, you can go to this page and see some implementations, some great implementations, or a very good repository that had a lot of samples about model context protocol. Also, you can go to the official page called modelcontextprotocol.io, and you can go directly for a specific SDK depending of your language. For Java, for example, is this one. And also, Microsoft is doing a very good job about communicate and giving some tutorials about MCP. And it has a very good repository called MCP for Beginners. Also, it has Java examples. And yeah, it's a very good repository. Well, let's go to the demo. Before the demo, I forgot why to use Java. Well, basically, as you know, Python has a lot of information, or has a lot of libraries that are working with large language models, but Java give us integration with enterprise systems. A lot of companies are using Java as his main language. Then it's a good reason to use Java to create our NCP servers. To communicate, for example, with APIs or with databases or so on. Also, Java provides us with high performance and concurrency kind of code or features. That's the word for that. And also, it's type safe. That it's as you know, it's better to have a language with type safe instead of other kind of languages. And it let us create complex APIs also. Well, now let's go to the demo. Okay, well, before go to the demo, let's explain what it's in our or how I create this demo. Well, I was using Spring Boot, but mainly to simplify some structures, like I am using the command line, for example. The communication that I will use is a standard I/O. That means my MCP server, it's not always up. It's just call it when it's required, when it is required. Well, it was I create a custom class that provides specific tools that could be used by the LLM model. Okay, well, let's see about the libraries I use. As I said, I just use Spring Boot to make easier the call of my MCP server. This library is to provide my MCP server with JSON RPC communication and also Jackson to translate JSON or to serialize the JSON's response or the JSON communication. This one is just the normal libraries for logging and also Lombok. Then, as you can see, it's quite simple. I am not using a lot of libraries in this example. Here I am explaining all of that. Let's see. Let's talk about a little about what is standard I/O. If we go to the official page, we can see here some examples of what we are using for the JSON RPC. For example, if we want to return audio content, this is the JSON RPC expected. Or if we are providing with some resources links, this is the JSON expected. Also, here are other examples about that communication with JSON RPC. Okay, well, let's continue with our NCP. Here is the server, my NCP server architecture. As you can see, I will connect my NCP server with IntelliJ. The communication will use standard input-output using JSON RPC. It will call my or this class, the standard IO NCP server. It will receive and process JSON RPC messages. And the implementations are based in this interface that it's called a base prompt that provides with some standard methods that all my tools have to implement. And finally, I return the information using, again, JSON RPC. And that's all. Well, let's see. Give me a moment. Let's see that in action. Well, here it's the NCP, I call it refactoring prompt. Here is just a configuration class. It is not doing a lot of things, just returning my standard IO NCP server as I call my NCP server. As you can see, what I will receive there, it's all the methods or the tools that my model can use. And that's it. I return JSON for that. The JSON has a name of my NCP that it's called a refactoring assistance, a version, and the list of tools that could be used. If we go to the base prompt, as you can see, it's just an interface with the methods that should be implemented in my tools. And let's see, for example, the design pattern prompt. This tool just returned a specific uh, uh, a specific prompt, template prompt, that provides to the LLM with some instructions about what we require to apply. Also, it can receive or not the design pattern we want to implement or in our code, or even we can tell him that review before the code, and maybe let us know what is the best pattern design to be implemented for that specific code snip. Also, if we want to apply a specific style for our code, we can create here again a prompt for that. In our prompt, we are telling what kind of styles we want to implement. For example, here I am telling him to provide the styles used by the Google Java Style Guide. And here I am telling to show the code following the Google Java Style Guide again. Also, I can implement or not with Lombok style, just sending an argument for that. And that's it. Here, for example, this one, it's applying just a style without Lombok. As you can see, we are receiving that from as an argument. And if we don't have that specific, if we have in the style only true, instead, we will apply the style format, but using Lombok to reduce the boilerplate. Here is the instructions to do that. Okay, well, let me look inside another one. This one is a dynamic prompt. As you can see, inside my prompt, I am adding some variables. In this case, just two variables, the language and the code. And it's quite simple to change that. The language will be here inside our prompt. And here is the code we want to analyze. That information is sent to the MCP server using the MCP client or using an agent AI. Okay, then let's go to the demonstration. Well, I did the demonstration using Copilot, but well, the MCP servers could be used by other MCP clients like the Gemini MCP client, the Anthropic MCP client, any of them. First of all, how to setting up our MCP client? Well, you have to go here. Let's call here a new one. Then you have to go to GitHub Copilot. You have to go to the agent mode. This one is the ask mode. As you can see, for the ask mode, it does not use MCP services. Then let's go to the agent mode. And here you will see the configuration tools or the configure tools. You can see all tools that are available for Copilot. And also here it's my assistant. Let's see here. And as you can see, I can say to my refactoring assistant what large language model I want to use. I told him to use Cloud, and well, here is save. And I forgot to show another thing that it's here. If you want to add another assistant, you need to click here and you will see this file. This file is configured for all GitHub Copilot. It's in my home folder .config / GitHub Copilot, IntelliJ, and MCP JSON. Here, I add the information about my MCP. As you can see, it's just the name on my MCP, the command I require to run, and the arguments for that will be the instruction jar or the parameter jar, and the jar I require to call. That it's this one. Then it is called when the agent required to use it. It's not running all the time in my local computer, but also if we are using an API, well, we have to have the API running, of course. Well, let's continue and let's see. Then let's go here, and I prepare a pet project with some problems that I want to resolve. For example, this one has two problems. It's a really long method with many responsibilities, and also has some code smells. As you can see here, we have a lot of ifs. We have a lot of responsibilities for our method. And also, we have some problems with if annotated. It's quite complex to read this method, as you can see. Then what I want to do is to telling to Cloud that help me extracting this method in different extracting this method in reducing the complexity of that. Then from my other ones, we have this method, the extract method prompt, to be sure that to be sure that GPT will or Cloud will use exactly my MCP refactor service. I can tell him to with the add with the add character and the name of my on my MCP service, and later telling what exactly tool I want to use, and that is what I will use it here. But also we can just tell in using the refactoring assistant extract method for this specific method. Then let's go there again. I will use the simple way, that it's this one, extract method. And well, let's just send that instruction. Let's wait for a while. Um, Let me see what it's. I forgot how much time it takes. Okay, well, let's say accept. As you can see, first of all, he creates some specific constants here that will help us in extracting the, well, or simplifying this information. It creates a lot of methods inside. And here it's a more clean method than what we have before. And it separates responsibilities using different private methods. And finally, it just give us this and log the summary, the order summary, and return what is expected. It's quite more simple. Here are all the methods that it creates, separating the by responsibilities, and it's more clean. And well, that's all what I have for you in my demonstration. And let me stop the presentation, or let me go again to. Well, any questions?
Thank you. Thank you very much, first of all, for your great presentation. Great dive into the MCP and stuff. So let's, we have a bit of time for the questions. So let's start with them. Do you have an idea how orchestrate tools in case, oh, sorry, it's just dropped. Yeah, so do you have an idea? Oh, come on. Just give me a second. I will copy it because it's just jumping from the feedbacks that your talk is amazing. So yeah, do you have an idea how orchestrate tools in case when we have big amount of tools and some of them similar? For example, 200. I suppose LLM will stack on using it. One person works with one input field for everything.
Well, the orchestration is managing by agents. We can have just one agent doing the or managing all the orchestration, and we have to review how we want to drive the orchestration in our agent AI. But it's something that the NCP server doesn't do. The NCP server is thinking to provide with tool resources, as I said, or prompts. Orchestrations is doing by our an NCP client, but most probably by an agent AI. It is more specific for that. Even at the beginning, I show how showing the example. Yeah, this one. Let me show this one again. Yeah, here, as you can see, the agent, first of all, goes to the LLM to get in a matching language what it's asking in the prompt. The LLM, it's well, is the unit, or yeah, we can call it in that way. Is the unit responsible for translate the prompt in matching language. Then later of that, it can provide to the AI agent with are the steps expected for to be achieved in the prompt. Probably for this prompt, for example, we have analyzed last week's sales and sent a report via email. Then the LLM will take this information, separate the different steps to requires for that. First of all, it requires to get the information about the week sales, and with that information, it will create or it will generate insights and create a report and all that steps, and finally send it that to a specific email that probably was introducing the prompt. That information is provided by the AI agent, and the AI agent will see the different steps for that. And in this part, it will orchestrate all the calls required to get first of all, to provide with the specific information to the LLM, and later send the information by email. As you can see, the AI agent await that information from the LLM at the beginning to get all the steps required for our orchestration. I don't know if that resolved your question.
Yeah, let's wait for the answer in the chat, but thank you anyway for the answer. Okay, another question we have from Vasily. A question on your implementation. How do you handle errors? Do you keep LLM in the dark and risk it instantly retrying tool call, or provided some context on what went wrong and how it should proceed?
We can provide our. Let me see. I have some examples here, but we can provide because we are using Java here. You can just through an error, or you can return a specific message. Giving what was the problem, trying to return the information required. For example, I could send the email in the example that we have at the here, or we can connect with the database. We can return that as an exception if we are using Java. But our MCP server will return that information in a JSON RPC answer for the AI agent, and he has to analyze what we return for that and take a decision about what to do with that information.
Okay. Okay. Thank you very much for the answer. And I think we're running out of time. So I want to say thank you one more time for your talk. Thanks
Okay,
for
thank
being
you.
part of Java One. Enhorabuena and mil gracias.
Muchas gracias. Have a good
Gracias.
day.
Adiós.
Adiós.